Hello, thank you for watching this video. So this video is question 7 of November 2023, question 7 mathematics paper 2. This is the application of trigonometry. You can see the 3D drawing that I've tried to draw here, right? No problem. So I'll read the statement and then answer the questions that follow. They are saying in the diagram, S, T, and K lie in the same horizontal plane, right? RS is a vertical tower. The angle of depression from R to K is beta, and the angle S of TSK is equal to alpha. TS is equal to P meters, and the area of triangle STK is equal to Q square meters. So let's look at this diagram. Yeah, they are saying in the diagram, which is this diagram here that we have, S, T, and K lie on the same horizontal plane. They are saying S, T, and K are on the same horizontal plane, which means they're on a flat surface like this. So you have your T, let's say here, let's say this is horizontal. You have T sitting here, you have K sitting here, you have S sitting there. So they're on the same horizontal surface, right? So it's more like, yeah, they're on the horizontal surface. You say, think of them as forming the ground, a horizontal ground. This S, T, and K, they're sitting on a horizontal ground. That's what you should be thinking about. No problem. They are saying now, RS is a vertical tower. So this here is a vertical tower. So you have your triangle sitting on a horizontal surface like this, right? You have T, you have K, you have S sitting here. They're saying now your RS is a vertical tower, is vertical, sitting over S like this. So you have all your 3 points at the base of your triangle, right? You have your T, you have your K, you have your S. And here at S, we have a vertical tower here, which is RS. That's what they're telling you. No problem. And then they say, the angle of depression from R to K is beta. They're saying now, let me try to draw this so that you can see. So it's easy if you try to separate these triangles. So let's separate them so that we don't have too much problems, right? So let's just try to carve this triangular pyramid up. Let's carve it open and see how it looks like. So if you look at this triangle here, you have four sides here. You have the base, which is the one that is sitting on. You have this front side, this triangle here. The front triangle, this is the second side. The third side is the one on the other side that you see from this side, which is this one here. Right? And the fourth one is this one over here. So you have a triangular pyramid here with 4 sides. The first side, or maybe the one that I'm highlighting first, is the base, which is the one that is sitting on the horizontal plane, with the one that this pyramid is built or sitting on, this triangular pyramid. So the first one is SKT. SKT, this is the first triangle that you have. It's the first side, which is the base of the triangle. The second side is this one over here. It's RSK. RSK. This is the second face. The third face is RTS. RTS. This is the third face. And the fourth face is the one that you can see from the front. It's RKT. It's the one here. So I'm going to carve these faces open so that you can see them with a better view. No problem. Let's go. Here's what I'm going to do. I'm going to draw it like this. So RKT, R. So here's R sitting here. So this is the face that you can see here. It's this front face that you can see. I've drawn it here, right? Yeah, so it's RTK. This is the front of this pyramid that you can see. What else are we drawing? Another thing that we're drawing the base of the triangle. This base of the triangle, which is this triangle here. So what does it look like? It's this one here, over here. So it looks like this. So you have K, you have T, right? And this is what? This is S. This position here. So this is the base of the triangle. So this is your alpha here. So here's the base of the triangle. It's this base over here. Right? What else are we given? We have this side, this right angle triangle over here. RST. So let's draw RST. RST will look like this. Looks like this. It's a right angle triangle, right? I try to use the same colors so that you can see which is which. So so the green one is this one here. So this triangle is, we have T here, we have S, we have R sitting over there. R is red, is that top one here, R. So we have 90 degrees. We have this 90-degree mark there, which is this one here. No problem. What else do we have? We have this triangle, RSK. RSK. So let's draw it. Looks like this. So we have a right angle triangle. So I have RSK. So R should be red. Anyway, should be red. Here's R sitting over here. And then we have this beta here. So beta is this angle over here. No problem. So this is what we have. So if we look from each side, if we're looking from the front, if you look at this pyramid from the front, this is the face that you see. Right? You see this face over here. So if you're looking from that side, this is what you see. You see this triangle like this. Actually, you'll be looking behind. You'll be looking at this triangle from behind. Then this one over here is this triangle over here, and the one at the base is this one over here. So for me, it's easy if I come and open like this. So and it will be easy to explain them. So I'll read the statement again. So let's go. That's saying in the diagram, ST and K lie on the same horizontal line. Like I said, ST and K lie on the same horizontal line. There they are. ST and K is this triangle over here. If you look at it separately, if you carve it out, it's this triangle over there. STK. STK. It's this triangle over here. No problem. That's saying RS is a vertical tower. RS is this height here, right? The height sitting exactly at S, going up the vertical tower. The tower is vertical. It's this one over there. So if you look at this triangle, you can see this triangle separately. Here is your RS, you have it here, and the RS also have it on this one as well. Because if you look at this triangle, you will have your RS on this triangle. Even on this one, you have RS, because there is RS. No problem. They're saying the angle of depression from R to K is beta. So the angle of depression, right, from R to K is beta. What do they mean by that? So you've dealt, I'm sure you have dealt a lot with the angle of inclination, the angle of elevation. So the angle of elevation, let's say you have your, let's say this is you. Let me draw you. So let's say this is you over here. Right? And these are your eyes. This is your eye. You are looking at something that is up here, right? So this is you looking up here. Let's take this dotted line as a straight line, right? You always define the angle of elevation as the angle measured from the horizontal into your line of sight. To your line of sight. That's how you define your angle of elevation. If I'm looking up like this, it's the angle between my sight and the horizontal. It's measured from the horizontal to your line of sight. That's what an angle of elevation is, right? So, if now our friend decides to look down, let's say he's standing on something here. I don't know what this thing is that he's standing on. Let's say now our friend decides now to look downwards, down here, right? So his line of sight now is this one over here. So the angle that is between the horizontal, this one here, let's say this is theta 2, and the first one was theta 1, this one here. This one here is also measured from the angle of, it's also measured from the horizontal to the line of sight, because this is also the line of sight. This is the line of sight. So this angle measured from the horizontal to the line of sight down here is the angle of depression, this one. Hope this is the correct spelling for depression. Looks like it. So this is the angle of depression. So the angle of depression is measured from the horizontal to a line of sight which is below the horizontal, right? As you can see, that the line of sight is here is a horizontal, and the line of sight is this one down here, right? The angle of elevation is this one up here. This is the angle of elevation. So it's measured from the horizontal up to your line of sight. That's the difference between the line, the angle of depression and the angle of elevation. So we go back to our statement. So to our statement, they were saying now the angle of depression from R to K is beta. So which means the angle from the horizontal, right? Because this is going to this direction in the same direction as this. This angle of this here is a horizontal, right? But now because it's coming to the same direction as this. So your angle of depression is this one, is the angle from the horizontal of R to this line of sight, which is this one here. But if you draw this separately like this, this is how it looks like. So you have this triangle over here, here is this triangle, right? So the angle of depression is this angle from here up to your line of sight, which is similar to this. Here's the angle of depression. Is this angle over here. But it's a bit tricky to see it from here because this is coming to this direction, which is, or maybe slightly outwards, which is not very easy to see. But if you carve them open, it's easy to see everything. So what I will do now, I will clean the board and then continue to answer these questions. But let me read the statement one more time. In the diagram, S, T, and K lie in the same horizontal plane. So S, T, and K, they're on the same horizontal plane. No problem. They're saying RS is a vertical tower. RS is vertical, you can see it. It's perpendicular to both T and S. As you can see, it's perpendicular to ST and to SK. Right? So this line T is perpendicular to SK and ST, as you can see there, as you can see here. No problem. They're saying now, the angle of depression from R to K is beta. So here's the angle of depression. Because this is coming to this direction. So they can't just say angle of depression and make it straight like that. This is a three-dimensional drawing. No problem. Then they are saying now, the length of TS is P meters. The length of PS is, the length of TS is P meters. What is TS? TS is this distance here. It's P. That's what they are saying. So here is TS is P, and you can also see it's this one here. It's P. No problem. Because whatever information or length that you find or angle, if you put it somewhere here on one of these triangles, you must also put it here so that it can be easy to deal with. So let me clean the board, and then now we answer the questions that follow. Okay, so now they are saying so in the diagram, S, T, and K lie in the same horizontal plane, right? So we said S, T, and K lie in the same horizontal plane, like I explained before. RS is a vertical tower. RS is a vertical tower, as you can see there, because I said that RS is perpendicular to ST and SK, as you can see here, as you can see there as well. No problem. They're saying the angle of depression from R to K is beta. So this angle here is beta, which is the angle from the horizontal to RK, like I explained. The angle of elevation, angle of depression, no problem. They're saying the angle S in TSK is called alpha. The angle S on TSK is equal to alpha. So that angle there is alpha, as you can see there. The angle S on TSK, because this is an isolation of the triangle. So I've isolated it and it looks like this. So that is alpha over there. No problem. They're saying TS is equal to P meters. So this length TS is equal to P meters. So which is the same as that length over there. It's P meters. No problem. They are saying now, and the area of triangle SKT is equal to Q square meters. The area of triangle SKT, the area of the base triangle of this triangle that is on the base, on the floor, is equal to K square meters. So we have the area of this triangle here is equal to Q square meters. This is the area, which is this area here. It's called Q square meters, which is the same area as this one here. Which is the same area as this one here. It's Q square meters. It's the area of this triangle here. No problem. What are they saying now? Listen to our questions. 7.1. What are they saying? They are saying to us, determine the length of SK in terms of P, Q, and alpha. They want us to find the length of SK. Where is SK? SK is this length here, which is the same as that length over there, right? But I'll look at this one separately. So, they want to find the length of SK, which is this length over here. So what do we know? We know that the angle S there, which is TSK, is equal to alpha, which is, we know that angle over there. What else do we know? We know that TS was P, so this length over here should be P as well. And also, yeah, it should be P. Let me also write it green so that these are consistent. So we know that this length TS is P. We're given there. You're also told in the statement that it's P. So what we also have, we have the length of one side of our triangle, which is TS. It's equal to P meters. No problem. What else do we know about our triangle? We know the area of the triangle. The area of our triangle is equal to Q square meters. No problem. Is there anything else that we know? No. This is all the information that we have. Then now what we're left to have to relate all this information that we're given, so that we can be able to find what? SK, the length SK, which is this length over here. But you know you're given the area. The area of our triangle TSK, right, is equal to what? Let me clean this. Don't like the way I've written it. So let's suppose that we want to calculate the area of this triangle here. We have the angle, we have the side. We need this side over here, right? Because to find the area of a triangle, you say, okay, the area of triangle, what? TSK. TSK is equal to half. What? It's going to be half this length here, which is TS, times another, this length over here. Because it's going to be half this side times this side, it's then sine of the included angle, right? Because that's how we find the area. You take take the product of half this side times this side and the sine of the included angle. So it's going to be half of TS times SK times the sine of our angle that we have, the included angle, which is alpha, angle S. It's alpha. Then now, we can say now, the area of triangle TSK is equal to half of TS. What is the length of TS? The TS is P, half of P times SK. What is SK? We don't have SK, it's what we're looking for. Times SK times sine of angle S. What is angle S? Angle S is alpha, sine of alpha. But they want us to find SK, right? We know the area of our triangle because the area of our triangle is Q square meters. So we can substitute our area here and say now Q is equal to, which is the area, equal to half of P times SK times sine of alpha. So we solve for SK because this is what we want. So we'll say that Q is equal to P sine Q, sine alpha over 2 times SK, right? Then you divide by this both sides. You will find that your SK, actually, let me do it. So you divide, let's say maybe you multiply by 2 over PS sine alpha. Then even here, 2 over P sine alpha. So this and that go away, this and this go away. So SK is equal to 2Q over P sine alpha. So this is your SK in terms of P, Q, and alpha, like they asked you to find. Done. But done. So if you are uncomfortable with multiplying by this, you could have cross multiplied. This times this times that, you would have come out the same. Cross multiplying would have been easier. Done. Then we move to 7.2. What are they saying at 7.2? They are saying, so now, actually, we know that SK is this. So what do? We put our value of SK here. Here's SK, which is this line over here. Is 2Q over P sine alpha. So it's this length over here, SK, is P SK is equal to P 2Q over P sine alpha. Done. That is your SK. No problem. So we move now. They are saying now, show that RS is equal to, they're saying show RS is equal to 2Q tan beta over P sine alpha. This is what they wanted to show. They wanted to show that the length of RS is equal to this thing. Where is RS? Where is RS? RS is this distance over here, this vertical distance there. That is what they wanted to find. They want to find this vertical distance here. You have SK to be this, right? Which is the same as this distance over here. Because this is SK, which is this, which is the same distance as this, which is the same distance as that. Your SK is 2Q over P sine alpha. So this is your distance over here. So they wanted to find RS, which is this side here. But you know this angle over here. This is 90 minus beta, this angle here. Because if this is beta outside, you know that this is 90 degrees in total. So this is 90 minus beta. So this one over here is beta. You can see these are alternating angles, right? Where you can do the triangle thingy. So this is beta over here. So you want what? You want RS. What is RS? RS is this. Sorry, you want RS. Where is RS? RS is this vertical distance over here, right? So you have the adjacent side. You have the angle. You want the opposite side. That's the tangent. So you can say that the tangent of beta, which is beta, is equal to what? RS, which is the opposite RS, over your adjacent side, which is what? Which is 2Q over P sine alpha. Because you have this side as an SK, which is this, which you just found to be that. Because the same side here, the same side here, the same side there. Because you'll be looking at this triangle because you want RS that side, which is this. So say the tangent of beta is called the opposite side over the adjacent side. So the opposite side is RS, which is what we're looking for. And the adjacent side is 2Q over sine alpha, which is that. Then what do you do? Cross multiply this, the numerator times this, is equal to that. So we'll say now your 2Q over P sine alpha is this tan beta is equal to RS. Therefore, your RS is equal to 2Q tan beta all divided by P sine alpha. Done. It is that. It is that. Then we're done. Go to the next one. Actually, the last one, which is 7.3. What are they saying? They are saying, calculate the size of alpha, which is, what is alpha? This angle over here. If your alpha is less than 90 degrees, right? So our alpha is less than 90 degrees. RS is equal to 70 meters. P is equal to 80 meters. And Q, the area, is equal to 2,500 square meters. And beta is equal to 42 degrees. So they wanted to find the value of alpha, right? So we are given what RS is. We are given the value of Q, given the value of beta, we are given the value of P. So you only listen that. This is straightforward. Even if you didn't know the first two questions, this one should be easy because out of this, you are given everything but that one. So they want you to find this. So what you need to say, RS, you know what your RS is. What is RS? You are given RS is equal to 70. It's equal to 2 times Q. What is Q? Q is the area, which is what? Which is 22,500 square meters times the tangent of beta. What is your beta? Your beta is equal to 42 degrees. All divided by what? All divided by P. What is your P? You're given that P is equal to 80 meters times the sine of alpha, which is what I'm looking for. This is straightforward. You wish they give you something like this all the time. So you cross multiply this times this, so you have 70 times 80 sine alpha is equal to 2 into 2,500 times tan 42, right? Then divide by 80 times 70, divide by 80 times 70. So this and that go away, so you're still left with sine alpha is equal to the answer of whatever this thing is. So if you punch that in a calculator, say 2 times 2,500 times tan 42, all divided by 80 times 70. So this is 0.0804. So alpha is equal to arcsine 0.804. Arcsine that is equal to alpha is equal to your 53.51 degrees. Done. This is straightforward. What you just need to understand is to carve out this. Once you carve out these things, you're done. Because you will know which triangles to look on. But if you look at it like this, it can be confusing. So I like carving it open and then doing it like this. So I hope this does make sense to you as it does to me. Thank you for watching.